Alright, looks like people are showing up. Good to see you. The attached PowerPoint is not the greatest of my work, and that's due to the fact that it does not like me writing radicals. And the way that it's going to look on the computer is going to be horrible. So I highly suggest you copy down some examples that I'm going to give you today on how to do them, but just typing them up is bad, especially in slides, because it doesn't give me that equation option. In docs it's pretty easy because you get that equation option, like insert equation. Slides it does not, so I have to go in and find the special character for the radical and put things in parentheses so I know it's under the radical, because it doesn't give that bar across. It's just a pain. So our examples will be given by me today, and you can kind of write them underneath if you printed out the slides, or you can take notes underneath each of the little topics in our slideshow today. So I do apologize for that, but it's gonna things today are not hard. It's just gonna look weird at first. You're gonna try to, I mean, you've done things like this already, is what I'm trying to say, but it just looks a little different with radicals, so you might not notice it. We'll give it another minute before we start here. Now let's throw in a couple more examples. Alright, it's 9:20, so we're going to get started. These are the first kind of things you're going to see. We're doing operations with radicals. So here you'll see we have two radical expressions, and they're either being added together or subtracted together. So first thing you need to realize is what's going on. Here we have the square root of 2 plus 3 square roots of 2. And first case we're going to look at is like radicals. So as long as the radicals are like radicals, very similar to like terms, you can add them or subtract them. So it is possible. If they are different, not so much. But we can add these radicals, and we're going to do it through the distributive property. Really, we're going to do it the long way first, and then you're just going to realize, oh, I can just do it that way and skip all the middle steps. So we'll do it with, first we're going to look at the distributive property with it, is where this comes from. If I can write. So this is the distributive property in play, which should be your favorite property by now, because it comes up everywhere. You will note just off the bat that this actually has a 1 in front of it, right? The square root of 2 is the same thing as 1 square roots of 2. So if I did put a 1 there, you can imagine there being a 1. With that, you should be able to factor out this square root of 2. Right? I can divide this term by the square root of 2, and I can divide this term by the square root of 2. I'm going to get rid of that. So it is your distributive product. What you're left with is 1 plus 3, and then you got to multiply it by the square root of 2, and that's going to be reduced down to 4 square roots of 2. So 1 square root of 2 plus 3 square roots of 2 is 4 square roots of 2. It should be pretty simple for you to figure that out. It goes a lot with, like, hey, what if we had x plus 3x, right? X here would be the square root of 2. We would just have 4x, right? You would combine your like terms. Over here, again, you divide out the square root of 5 from each, and you get negative 3 minus 4 square roots of 5. Negative 3 minus 4 is negative 7 square roots of 5. Again, if you just did x equals the square root of 5, you have negative 3x minus 4x, you get negative 7x. You've done that forever, right? Over here, again, you don't really have to do this step here. You can skip the distributive step. You just have to realize that's what's in play that makes this possible. But this here, remember you have a 1 in front, so 1 square root of 10 minus 5 square roots of 10 is negative 4 square roots of 10, because 1 minus 5 is negative 4. And then you just tack on the radical. So that is not really difficult, because you've been doing things similar to it this whole time with combining like terms. But it is combining like terms. Your like terms are just your radicals, and you can add and subtract them as long as they are like terms. Which brings us to our next case, which is, what if they aren't like terms? Well, sometimes you can do it, sometimes you can't, but we're going to call that, it says, the book calls it simplify to combined like terms. So part 2 of today. Let's get rid of all this. The second thing you need to know for today, oh, wrong button, there we go, is part 2, where your book calls it simplifying to combined like, it's not terms today, it's radicals. So let's get a few examples up here. So example 1, let's look at 7 square roots of 3 minus the square root of 12. In this case, your radicals are not like, so you can't just add them or subtract them, very similar to like fractions. So do we have to do 1 through 33 on the document today? I don't know. What is today's assignment? I called it 10 through 33, but then I wrote 1 through 33. It probably is 1 through 33. That probably is a typo. Let me see if we have anything tomorrow. What are we doing tomorrow? No, we're continuing this tomorrow. So if you have 2 days to get that done. I would look at it and do some today. I mean, we just went over, well, you should be able to do number 1 now. In fact, you should be able to do 1 through 6 right now. Shouldn't be too difficult for you. So, I don't know. So what we're looking at here is simplifying and then combining. This can get a little tricky if you don't notice things, but again, we're looking for factors. So here we have the square root of 3. Is the square root of 3 a factor of the square root of 12? It actually is, because I can reduce the square root of 12. So what I'm going to do is I'm going to pull the square root of 12 out, and I can reduce that. Remember, the square root of 12 is the same thing as 3 times 4 is 12, so that's the square root of 3 times 4, and therefore that's going to equal the square root, I'm going to write the square root of 4 first because I can actually reduce it, times the square root of 3, which therefore equals 2 square roots of 3. So if I write it that way instead, right, so instead of writing it like this, I write it as 2 square roots of 3. They are now like radicals, and I can combine like I just did, and 7 minus 2 gives you 5 square roots of 3. So once you get them as like radicals, you can then reduce it like we just did in part 1 of today. Now this can get a little tricky if you don't notice any like radicals, like Here we're looking for 3, and I know 12 has a factor of 3, so it's going to work. Well, the factor of 3 with 12 is a perfect square, so it's going to work. But sometimes it just doesn't quite work out, and you can't really do much with it. So there are some other tricks that you kind of throw at it. So let's look at another example here. Get rid of this. Let's look at 3 square roots of 20 plus 2 square roots of 5. You'll note we're still doing operations. We're still trying to add these two together or subtract. And we're looking for a factors like to simplify one of these. This one you cannot simplify, but this one you can. And you'll note that 5 is a factor of it. And it happens that the other factor, right, 5 times 4 is 20. 4 is the perfect square. So that's a dead giveaway that this is going to reduce into something that will combine. So we're going to go ahead and reduce 3/20ths, which we're actually going to ignore the 3. Just reduce the square root of 20 here. And again, that's going to be the square root of 4 times the square root of 5, because 4 times 5 gives you 20. So this is going to be 3 from up here times 2 from here times the square root of 5. And 3 times 2 is 6. So this is actually going to turn out to be 6 square roots of 5 plus 2 square roots of 5. And therefore you can just combine like we just did. They are like radicals. So 6 plus 2 gives you 8. And then just tack on square roots of 5. So it does equal down to that. Let's do another one. Once you get the hang of them, they're not hard. It's just a little awkward at first. Let's give myself some room. Let's look at another example. That's going to annoy me. Another example is 3 square roots of 3 minus 2 square roots of 27. And you'll note that 3 is a factor of 27, and it just so happens that the other factor of it, 9, 3 times 9 being 27, is a perfect square. So we're going to go ahead and reduce this side here first. This side you can't really reduce, but we're going to reduce this one. Again, you don't really need to bring the 2 down. We're just going to remember it's there. We have the square root of 27 is equal to the square root of 9 times the square root of 3. And the square root of 9 gives you 3 square roots of 3. And don't forget about the 2. We're just going to multiply the 2 in there, because technically there's a 2 there, technically there's a 2 there, and technically there's a 2 here. So this is going to equal 6 square roots of 3. So then we can go ahead and replace that with that. So we get 3 square roots of 3 minus 6 square roots of 3. And again, using your distributive property, combine like terms, 3 minus 6 gives you negative 3 square roots of 3. And that should be your final answer. Not too difficult. Just takes a little noticing. See if you can notice things. Any questions on those two things? I feel like I rushed through them, but if you're not questioning it, we're going to move on. Oh, that did not. I'm doing great here. So the third topic we want to look at is using the distributive property. This is a little different than what we just did with the distributive property, but I'll show you. This is like your common distributive property stuff. Like example, we have the square root of 3 being distributed to the square root of 6 plus 7 or something. Right? So here you want to look at, hey, I can distribute to that and to that. In doing so, not too difficult really. You just kind of distribute it. like you normally would. So you have the square root of 3 times the square root of 6. So using your multiplication property of square roots, that is the square root of 3 times the square root of 6, which is the square root of 3 times 6, which is the square root of 18. I don't even know if there will be a math test, Audrey. It depends on how far we get. As of right now, I plan on teaching for the next couple weeks here. Let's look at the calendar. Let's see, the 29th here is your last day. I plan on teaching next week and giving you this last week to just do missing and makeup work. That's what the plan was. I mean, actually, it was from the 20th on, was just missing and makeup work for you to get everything in. So we probably won't have it. If we do, it'll be the 20th, but we probably won't have a test on it. That's what it's looking like. Again, I'm just trying to expose you to as much math as I can. Oh, the test will be in. Oh, I do not. I still have some people who haven't taken it or are still finishing it up. So I don't really want to go over it until they've had a chance to look at everything. I'm hoping by the end of this week, which will be tomorrow, probably Monday. But we are kind of getting down to the end here, and I got to stop assigning more work. But I also feel a lot of you are keeping up with it and deserve to learn. So let's see here. We got, again, the square root of 18 from that. What are we doing? I don't even know what we're doing. Distributive property. Okay, so the square root of 3 times the square root of 6 gives you the square root of 18. And then the square root of 3 times the square root of 7 is going to give you plus 7 square roots of 3. And then you think, is 3 a factor of 18? It is, but is there a perfect square there? Not so sure about that. So it's not looking like we can combine these two. But maybe we definitely can reduce this one. So let's go ahead and reduce this one and then see if we can combine it after that. So let's go ahead and reduce the square root of 18. The square root of 18 is equal to, any perfect squares in there? 9 and 2. Yeah, I guess what we should be able to combine. No, because 9 is going to become the, yeah, you're going to get 2. So we get 9 times 2, which is the square root of 9 plus, or times the square root of 2, which equals 3 square roots of 2. And that was just reducing the 18, right? So we're now left with all of it together is 3 square roots of 2 plus 7 square roots of 3. They are not like terms or like radicals. You cannot combine them. They're both simplified. Can't combine them. So this here is as simple as you can get. So this here would be your answer for this. So this thing here is equal to this. And again, you just distributed and then simplify the radical where we could. So let's get another example of that one. Let's just give me some space. So let's get another one going there. We get the square root of 5 times the quantity 2 plus the square root of 10. And again, you're going to distribute to each of them. So here you're going to get square root of 5 times 2 is 2 square roots of 5. Square root of 5 times 10 is, well, 5 times 10 is 50, so that's the square root of 50. 50 is reducible, so we're going to go ahead and reduce that. Go off to the side here. 50, you should note, we definitely have the square root of 25 in there, times the square root of 2. So in that case, 25 is going to be 5, square root of 2 is going to be 2. So it's going to equal 5 square roots of 2. So you have 2 square roots of 5 plus 5 square roots of 2. And you cannot combine them. Your radicals are not like. This is a square root of 5 and this is a square root of 2. Cannot combine them. Could you do 6 and 3? Instead of 9 and 2. Did I ask you to do odd ones? What did I ask you to even do? Never. Oh, then you said never mind. And then Adam asked for number 2. Could you do 6 and 3? No. Oh, okay. For factors, 6 and 3 I would not do because neither of those are perfect squares. Again, you're looking for perfect squares. 9 and 2 worked well because 9 is a perfect square. 6, I can't take the square root of 6. I don't know what it is. And 3, I can't take the square root of 3. I don't know what that is. Oh, well, you can. You're just going to get an ugly number. So the reason I did 9 and 2, right, square root of 18, I did as the square root of 9 because I can solve this in the square root of 2. Right? If I did 6 and 3, I don't know what that is, and I don't know what this is. So you need to pick one that is a perfect square. So you're looking for perfect squares, which again, you should have a lot memorized, like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, however much I guess. So you're looking for these ones to take out. So when I have 10 here, like the square root of 10, I'm not going to simplify that because I don't have any of these that are factors of it. Yeah, I have 5 and 2, but the square root of 10 is simpler than saying multiply by the square root of 5, then multiply by the square root of 2. But this is number 2 for Adam. Adam, you just add 16 and 2. 16 plus 2 gives you 18, and then you tack on the square root of 10. Right? Because they're like radicals. So 18 square roots of 10. And again, you don't want to reduce that 10 because it doesn't have any perfect squares in it. Right? If you were to reduce it, it would be like 18 times the square root of 5 times the square root of 2, which is ugly, and you would end up writing it as 18 times that, which you might as well just write it as 18 times 10, or the square root of 10. So you can't simplify everything, especially if it's already simplified. Following in the book here, where's the next one? Okay, let's look at more distributive property ones. Let's do one more example of distributive property. Let's do square root of 5a times square root of 5a plus 3. Sometimes you get things that are like this, and just use what you know about square roots. Right? If I'm going to sit here and say the square root of 5a times the square root of 5a, right? The square root of 5a times the square root of 5a equals the square root of 5 times 5 times a, which equals the square root of 5a squared, which just equals 5a. The square roots here are going to cancel out. So when I do that, I'm just going to get 5a. And then I'm going to multiply 5a by 3, and I get plus 3 times 5a. And there is not much I can do after that. So just be aware when things happen like that. The square root of 6 times the square root of 6 plus 2 or something like that. These just become 6 because they're multiplying them by themselves, and then plus 2 square roots of 6, which that gets reduced. Does it? No. Right. So just be careful with, multiplying the same square root by itself when you're squaring it, and therefore you're going to get rid of the square root, because that's, the definition of a square root. Any questions so far? I feel like I'm going fast through this. I didn't think it was that easy to catch on. I mean, it's easy to do once you get it, but I thought it would take a little more questions here. Next is foiling. Foiling radicals. Yeah, it sounds difficult because foiling was kind of new and scary, but you're pretty good at it by now, and it is just the distributive property, and you are just, distributing like you normally do when you FOIL. So let's say we have the square root of 5, let me copy this right, minus 2 square roots of 15 times square root of 5 plus square root of 15, right? You are just going to FOIL it. And remember, FOIL first, outer, inner, last. So the first one's the square root of 5 times the square root of 5. Well, that is 5, because I just told you before. That's going to be the square root of 5 squared, which is just 5. Then you're going to do the square root of 5 times the square root of 15. It is a positive, so it will be a positive square root of, and then 5 times 15 gives us some number. Is that 75? Yeah, that's 75. Gives us a square root of 75. Then going to take 2 square roots of 15 times the square root of 5, and that's going to give us, let's see here, just looking at it, I'm not sure we can reduce much there, but it is negative because this is a negative, and then 15 times 5 gives us another 75, so that's 2 square roots of 75. You will note that these are common, and we can combine them later on. And this times that is going to give us a negative, because this is negative, 2, and then 15 times 15 is something big. Oh wait, that's just going to cancel out and be 15, because it's going to be the square root of that, which will be 15. So times 15, just group that together. I guess we'll stick the negative in there. Right, so we have the negative 2 times the 15, because the square root of 15 times the square root of 15 gives us 15. So with that, combine your like terms just like you would in foiling. You'll note that your two inner terms should always be able to combine, just like they did in foiling. You should have like radicals there. I can't do anything with that 5 just yet, however I will later. I'm going to combine these. I have a positive 1 square root of 75 and a negative 2 square roots of 75, so that's going to become a negative square root of 75. And then over here I have negative 2 times 15, which is negative 30. Here you are more than welcome to combine your 5 and your negative 30. if you want to do that first, or we can reduce this. We're going to reduce that first. I don't think it's going to matter, but yeah. I mean, it doesn't matter. You can't combine those. Let's reduce this first, though. This is going to equal 3 square. I'll do it. Well, let's do the square root of 25 times the square root of 3. So that is 5 square roots of 3. So this is going to become 5 minus 5 square roots of 3 minus 30. And you can do, I'll lose a sign anywhere, did I? No. Then the positive 5 minus the 30 is going to give you minus 25. Or you could have brought it to the other side. Yeah, your book brought it to the other side. Did it? And oh, this is negative. Just be careful. So foiling it. You're just kind of combining everything from parts 1, 2, 3, and 4. Well, this is part 4 for today. Right? So it is the same process. Just be aware you have radicals instead of variables here. And sometimes they even throw in variables to them. Because, you know, life's hard. Let's look at another example. Let's do 2 more of these. And then we'll do the conjugate tomorrow. If you're working on your homework and you come across problems that have denominators, fractions, things like that, 28 through 33, I'll tell you how to do those tomorrow. And then we'll finish those off tomorrow and see if we have any questions. Make tomorrow a fairly easy day too. But let's look at another example of foiling here. 6 plus 3 square roots of 3 times square root of 6 minus 5 square roots of 3. Alright, so we're going to go ahead and do our first. You'll note that 6 square roots of, or the square root of 6 times the square root of 6 can be combined here, just like they are like term. Oh, well, we're not adding them, we're multiplying them, so when you multiply them, it's going to be 6. So it's going to be 2 square roots of 6 times the square root of 6, which is going to be 2 times 6, which is going to be 12. Should I write that all out for you? I'll write it out over here. 2 square roots of 6 times the square root of 6. This becomes 2 square roots of 6 squared, which becomes 2 times 6, which equals 12. So that's how I'm getting 12 for my first term. My second term will be my first times my last. Or my outer ones. First times my last. Over there, you're going to be getting 2 square roots of 6 times negative 5 square roots of 3, which is going to be 2 times negative 5, gives you negative 10 square roots, and then 6 times 3 of 18. I don't know if I want to reduce that just yet. I'm just going to tack it on. But it can be reduced. Here we're going to do inner. 3 times that, this is positive 3 times the square root of 18. See, one reason I didn't reduce that was because I can combine these now and then reduce it afterwards. If I reduced it first, this one here would also have something that I can combine with it, so it's really not going to make much of a difference, but it's going to add less clutter to this step right here for me. So that was really the only reason I didn't reduce that right away. But you're more than welcome to. I don't know why my arrow is going both ways. And then I'm going to do this times that, which you're going to do 3 times negative 5 gives you negative 15. Square root of 3 times the square root of 3 gives you 3. And 15 times 3 is 45, so that is a negative 45. With that, I'm going to go ahead and combine my middle terms here, just like you do always when you FOIL. And I'm not going to touch the 12 and 45 this time. I'll do it right after. This is a negative 10, and this is a positive 3, so this becomes a negative 7 square roots of 18 minus 45. I am going to either, I mean, again, you can, doesn't really matter what order you do this in. You can combine these like terms, or you can reduce that first. Let's combine these like terms. We have 12 minus a negative, or a positive, 12 minus 45, which is going to give us 33, and that is positive, and then minus 7 square roots of 18. Then I'm going to take 7 square roots of 18 and reduce that. I'm just going to do it down here. So this is a negative, so keep that in mind. 7 square roots of 18 is going to reduce down to negative 7 square roots of 9 times square root of 2. Square root of 9 is 3, so negative 7 times 3 times the square root of 2. That becomes 27 square roots of 2. No, 21 square roots of 2, because I can't do math. 21 square roots of 2, and it's negative. So this is going to be 33 minus 21 square roots of 2. And you're going to have to leave it like that. No, it's not. This is negative. This is a negative 45 plus a positive 12. Gives me a negative 33. So watch your signs. Just double checking what I did, making sure things make sense. You could also look in the book and see what the answer is there. Yeah, that's that's your answer. I would like to do one more with you, and it's not. Gotta actually delete everything. And this one here is going to be done with the perfect square. So the square root of 7, square root of 7 plus 4, and then that's going to be squared. So this is a perfect square, as it is, because, well, if I took the square root of it, right? So remember, this is equal to square root of 7 plus 4 times the square root of 7 plus 4. And then when you do your first, you're going to get 7 times 7, or the square root of 7 times the square root of 7, which is 7. Square root of 7 times 4 is going to give you positive 4 square roots of 7, plus another 4 square roots of 7, plus another 4 square roots of 7, it looks like. And then all of these can be combined. Did I do that right? I missed something here. Oh, that's because this isn't the right last term. I'm not taking first and last again. I'm taking that and that plus 16. That's where not making sense. So you get that. Here we're going to get 7 plus 16, which gives you 23. And then 4 square roots of 7 and 4 square roots of 7 become 8 square roots of 7. So there you have it. Tomorrow we're going to look at the conjugate, which really is not difficult. It's actually pretty easy. But it will solve all of your denominator problems. So if you have questions, email me. We are getting down to the end here. So stay on task of things, and I will talk with you tomorrow. Again, we're just going to continue this lesson tomorrow. So if you don't finish that page or you have questions on that page, we'll go over them tomorrow. All right. Bye.